All right, grade 12. Here's the last video of work, energy, and power. I'll see if I can couple this with one of the question 2 past papers. We'll see if we still have enough time. So this is 2019 Department of Basic Education 2019. Question 5. A statement says 70 kilogram block is initially at rest. So VI is 0. Initially at rest, VI is 0 at the bottom of a rough plane. So this means that we have friction. It means we have friction. There's frictional force. At an angle of 30 degrees to the horizontal, the box is pulled up the plane by means of a light inextensible rope held parallel to the plane, as shown in the diagram below. The force applied to the rope is 700 newtons. So this is F applied, force applied. This is applied force of 700 newtons. What is the name? Number 1. What is the name given to the force in the rope? The name given to the force in the rope. The force applied is 700 newtons, but the name given to force in the rope is tension. Tension force is a force we find in strings, cables, or ropes. Anything that we use to pull an object, this tension force. 5.2, give a reason why mechanical energy of the system will not be conserved. So they are already telling us that mechanical energy will not be conserved, and why. Remember, they mentioned that the surface is rough, there's friction, and mechanical energy is only conserved when there is no friction, when there is no applied force, and when there is no tension. So there is frictional force and there's applied force also. So mechanical energy will not be conserved. It's because we say that F net, the net external force, is not 0. You can say the net external force is not 0. Or someone will say there is frictional force, that will still be correct. Or there is applied force, that will also be not correct. But I would prefer F net is not conserved. Once there is friction, it's easy, just write net force is not 0. I mean, not F net is not conserved, excuse me. Made a mistake there. Let's move to the next one. It says the box is pulled up over a distance of 4 meters. So they are telling us that delta X is equals to 4, because along the incline is X is equals to 4 meters. The kinetic frictional force between the box and the plane is this one. This equals to Fk. Number 5.3, draw a labeled free body diagram. Draw a labeled free body diagram of the box as it moves up the plane. This is 3 marks, people. Free body diagram, you hear the word free body diagram? So let's draw it. It's 4 marks, so it tells us there are only 4 vectors. Sit next to the diagram. So it's make our dot bigger. So up the incline we only have applied force, or we can write tension force. Still be not correct. Applied force, I think applied force makes sense because that's the force they apply to pull an object up. Then we have the weight. In the previous videos I showed you how you get these marks. I made a few videos on TikTok as well as on YouTube. Check them out. The object is on the surface, so there's definitely tension. Tension is only when the object is on the surface. When an object is hanging, there is not tension, I mean normal force, excuse me, normal force. Then the other force is the force that is caused by the rough plane. The object is going up, so this force goes in the opposite direction. And there we have it, 4 marks. There is no any other force except this 4. If you're thinking of any other force that I did not write here, wrongly. So 4 marks, like that, easy. Remember, the weight has components now because it's on the incline. It has the perpendicular component, which is always going to be equal to the weight in most cases, not always, most cases. And it has the parallel component, which is always directed down the incline. Always the parallel component of the weight is directed down the incline. If you make your free body diagram like the one on the left, you'll have applied force, normal force, and then instead of writing, let's just have frictional force. Now, instead of writing the weight downward straight, when our Balama components like this, the perpendicular component, we say it's perpendicular component because it's perpendicular to the surface, né? And it's always along the same line as the normal force. It's straight. If you make it roll along, it must look straight. And then the other one, the last one, is if you have the perpendicular component, you are going to have the parallel component, FG parallel. Now notice now that we have 4 forces. So we have the normal force, the applied force. Why did I write FG? This is applied, FA. We have the applied force, and we have friction, 3. These 2 forces, they represent one vector. They represent a weight. So both of them should be there for you to get the 4th mark. If you pala A1, hi, we don't give half marks, only get 1 or 0. So your free body diagram, any of the 2 free body diagrams will be accepted. Notice my free body diagram is not quite perfect. It's fine. We will not be using something to zoom in to display the angle between the 2. It's fine like this. So we get 4 marks. Then 5.4, calculate the work done on the box by frictional force over the 4 meter distance. So the forces that do work on an object, if you look at this diagram, it will be the frictional force, the applied force, and the weight. If it's the same even if you're using this one. Okay, we don't have the vertical height for us to use the weight. It's fine. You can use this the parallel component of the weight. So it's still going to be 3 forces because it's 1, 2, 3. This one will be perpendicular to displacement, so it does 0 work. So let's write down the formula that we are going to use. It's going to be work done by frictional force equals to frictional force delta x and the cosine of the angle between the 2. Notice it 3 marks is guiding you. The formula also you is a direct formula. You don't have to use the energy principles. Those will be, they are worth 4 marks or more. If you are using a direct formula, work done by frictional force, work done by weight, it should be only that formula. Work done by frictional force is frictional force, the displacement, and the cosine of the angle between the 2. And the size of the frictional force is given to be 178.22. 178.22. Delta x, or the displacement, is given to be 4 meters. Remember, all these things are positive, not direction. You don't have to choose direction when you're dealing with now in question 5, no direction. Now negative is sorted out by the angle. Now what is the angle between the 2? The object is going up. The object is going up, so displacement is always facing where an object is going. The object is going up, where is the frictional force facing? So one is facing up, the other is facing down. These 2 are parallel but in opposite direction. So the angle between them is 180, cos 180. Or you can just take it with if frictional force, the angle between the frictional force and the displacement is always 180. You will never be wrong. It's always the case. Well, if you take it like that, frictional force and the displacement, they are apart by 108 because frictional force is a force that opposes the motion of an object. It's always in opposite direction. Now put this in a calculator. 178.22 multiplied by 4 multiplied by the cosine of 180. I-calculator izokunikeza negative 712.88. Negative 712.88 joules. And this is 3 marks. It means it's a formula, the substitution, and the answer with unit. Is substitution layer, okay? and the answer should remain negative. It's work done by frictional force. So we are done. We have taken 1, 2, plus 4, plus 3. 9 marks in out of 15. Now the last one. Oh, not the last one. 5.5. Use energy principles. Again, the examiner is channeling you now. You are not allowed to use any other thing that is not an energy principle. Use energy principles. Remember them. I3. Since there's friction, we forget the first one. The conservation of mechanical energy. Forget about it. Consider the last two. The work energy theorem or the work done by non-conservative force. You can use any one of them. It will work quite well. So this is 5.4. The free body diagrams are 5.3. 5.5, I think we need more space. 5.5, if this notice is not enough, we'll see. So let's use work done by the net force equals to the change in kinetic energy. We can also use work done by non-conservative force, but I'm avoiding that one because you don't have the vertical height, unless we use sine to calculate the vertical height, but we don't need to go through that stress. It's fine, just use this one. This will be work done by friction plus work done by parallel component of the weight, because now vertical height, don't use weight straight, use parallel component of the weight because you're given the displacement along the incline. Plus, is there another force that does work on the object? Yes, is work done by applied force. This is equals to the change in kinetic energy. So work done by friction, let's just leave it as it is because it's given. We see calculated in the previous question. Plus work done by parallel component of the weight. So this will be FG parallel. FG parallel, remember FG parallel is always mg sine theta. Always. This is mg sine theta, the parallel component of the weight. It can never be cos, it's always sine. Multiply by, this is the force multiplied by the displacement, and then the cosine of the angle between the two. We use theta here, let's use a different notation. Plus work done by applied force. So this is the applied force because it's given the displacement and the cosine of the angle between the two. I'm using beta because but even if you use theta for all of them, you will not be marking that. Just want you to just know to the angle a balloon. Then this is 1/2 mv final squared minus 1/2 mv initial squared. Remember, I said you must write it like this to avoid making mistakes. If you are struggling with it, if your maths is fine, then you can write it the way you're comfortable with it. So now let's substitute everything. The work done by, I'm going to move to the left a bit because we need more space. Work done by weight, our answer, even if it was wrong, it's fine. Substitute it. 0.88 plus, substitute together with the sign, plus mass of the object is 70 times 9.8, and the sine. This angle is not the angle between the two, is the angle of the incline. So it's 30. The displacement is 4. Now this is the angle cosine of the, this is the angle of the angle between this force and this displacement. Remember, this is a force. This is our force, FG parallel. This is a displacement. What is the angle between the two? So let's go to a Fibonacci diagram again. FG parallel, okay, in this one I don't show. The object is going up. Displacement, this is displacement. It's going up. FG parallel, look at in the Fibonacci diagram, FG parallel kale. So nakaqala I angle layer is phambene 180. 180 plus applied force 700. The displacement is 4. Now the angle between the applied force and the displacement, any Fibonacci diagram will work, anyone that you choose. The object is going up, the applied force is going up. They are parallel and facing this, they are facing the same direction, 0. Or even if you're using this one, the object is going up, the forces applied is going up. So the cos, this will be cos 0. Nasiqale ndawonye, angle go 0. 1/2, then the mass 70, final velocity of the object. Calculate the speed of the ball after it has moved. So this is what we're looking for. Leave it as it is, minus 1/2, 70, and the speed of the object where it started, this was 0, but here it was initially at rest. That's why it's below 0 initially at rest. So we have substituted everything. Do your calculations and find a final velocity to be okay. I'm going to do all these numbers on the left. This one disappears because everything multiplied by 0 makes that thing to disappear. Everything on the right, divide by 35, because half of 70 is 35, and then the square root of everything. So let's say the square root of everything, this will be minus 712.88 plus this is no, I made a mistake. Excuse me. The square root of the fraction 35 below, then on top we have negative 712.88 plus the bracket that is 70 times 9.8 and 9.8 the sine of 30. Close that bracket. Remember, calculator now for sine 30, if left bracket, close it. And this is multiplied by 4 multiplied by cosine of 180, cos of 180, and make sure we close that bracket as well. Let's close this one also, and then plus everything plus 700 multiplied by 4 multiplied by cosine of 0. Now if you press answer, you'll get, it takes forever to think, 4.52 meters per second. Now they said the one speed of velocity. Let's see. But Bafuna is speed. Remember, speed is a scalar quantity, not direction. If they said velocity, in which direction? But because it's speed, no, it's fine. This is final. 5 marks. How do you get 5 marks? You write the formula. You copy it from the formula sheet. We give you a mark if you substitute on it. You write the formula. The right hand side, the substitution you okay is 1 mark. Because it's 5, the answer will be 1 mark, and then the other 2 marks will be here. Positive marking for this number. So this substitution is 1 mark. This substitution is 1 mark. Positive marking from the previous question. Here, this number. If, say for instance, your answer was incorrect in 5.4, you use your number here, you will not get this answer. Yours will be different, but you'll get positive marking, you'll get full marks, because I want to take our calculator CBAL. If you get your answer, should you calculate it correctly, you get all the marks. Folks, this is how you do it. 5.5. Go through the step, do it step by step, and relax. Don't rush it. If you are comfortable with calculating this one alone on the side, calculating this one on the side as well, and then later on put them together, it's also fine. Now the last question, 5.6. When the box is 4 meters up the incline, the rope accidentally breaks, causing the box to slide back down to the bottom of the incline plane. So when it was here, this rope air breaker, the box moves backward. What will be the total work done by the friction when the box moves up and then down? So let's think. Now let's use a black. When the box was moving up, the work done by friction was negative 712.88 joules. It is when it was just moving up. When it's moving down, it is, let's see, Work done by friction will be the same size. The frictional force will still be the same size because it's still the same inclined plane, the same blocks, the same block, and the same inclined plane. So the force will not change. The force is only changed when you change the incline, the angle of the incline, or when you change the surface itself. So this force will remain the same. The distance over which this block is moving is still going to be the same. Now, what will be the cosine of the angle between the friction and the displacement? Remember what I said. The angle between friction and the displacement is always 108. So this will still be minus 712 because the two values are the same. The angle is the same also. Minus 712.88 joules. We don't take direction like it's a scalar quantity. Now, when you add these two numbers, what do you get? When you add them, you get a total of this number times 2. So it's negative 712.88 times 2. This will be, or you can say negative 712.88 times 2. And this will give you negative 142.76 joules. You don't choose direction. It cannot be 0. If it's 0, it means one of them is positive, and work done by friction can never be positive. Rest assured, it can never be positive. Work done by friction is always negative, and if it's over the same distance and the same force, that number double. So the answer here will be this one mark. They will not ask you to, or they did not ask us to explain. If you just write this number only, it's still going to be correct. Or you can do it step by step, it's fine. But I was just doing step by step so that you understand why is it double. So that is it for question 5. I believe what I've done will help you to understand this question better. So if you don't understand the question still, just before you write on Thursday, I'm going to do a live video, I think on YouTube, and I'll share the link on my TikTok, and you all can watch, and we do more questions. You'll send me the questions up. I'll check them out, and then we will do them so that you are prepared before you write on Friday. Now let us look at another paper here. I have question 2. I believe question 2 and question 5, they have something in common, and that is the free body diagram. The issue of the free body diagram, I believe that is common in these two questions. That thing is it's 3 marks. The examiner is being too kind nakanikela ama-marks lawa free body diagram, and wena nongafuniko nasazi ubona sikwenzeni, sazi ukuthi siwathathephi. Excuse me. Let's look at this one. Initially we did in the other videos we did a free body diagram. So this was shown in the other videos, free body diagram of block P. Says block P of mass 2 kg is connected to block Q of mass 3 kg by a light inextensible string. Both blocks are on a plane inclined at an angle of 30 degrees to the horizontal. Block Q is pulled by a constant force of 40 newtons at an angle of 25 degrees to incline. Block P moves on a rough section AB. So section A and B is rough, while block Q moves on a frictionless section BC. So from B to C, there's no friction. Also notice that we are given the angle of the incline that both these blocks are on. So this angle will affect FG parallel, will affect the weight. It's going to give us FG parallel. Notice that we are not given any vertical height, Lane. So it means we are going to use the FG parallel thingy. We must find the components of the weight. So there's another angle for the applied force. The applied force is not parallel to the horizontal. This was a bit difficult question because of an angle, the applied force at an angle, and the object is on an incline. So, but yeah, let us do it and see. An average constant frictional force of 2.5 newtons acts on block P. Remember, Q does not have friction. This one has friction as it moves between A and B. Number 2.1, state Newton's second law in weights. This definition, it is basically this formula. When you have to, if you forget it, just remember this formula: F net equals to MA. F net equals to MA, and rearrange it in a way that, in such a way that acceleration will be the subject of the formula. So if you rearrange that, you divide by mass both sides, it says F net divided by mass. If you read this, okay, this is first part of the statement where you say when a net force acts on an object, the object will accelerate in the direction of the net force. Then the second part of the statement that says acceleration is directly proportional to the net force and inversely proportional to the mass. Please make that statement correct, because what we normally see is learners confuse the two. They start by saying the net force is directly proportional. Just take this formula, and is this formula, just rearrange it, make A the subject of the, when you define it only when you define this thing. So acceleration is directly proportional to net force and inversely proportional to the mass of an object. It's 2 marks. In weights, don't do this. Don't do this. You are going to write it in weights and then you get marks I2. 2.2, draw a free body diagram, a labeled free body diagram for block P. Okay, something that you notice the videos in Wenzile free body diagram, they were on sound, there was no sound. But note here, students, a free body diagram, if it has all the vectors correct but agnama labels, you will not get a mark. You will not get marks. If your free body diagram has no arrows, it doesn't show the arrows, you will also not get a mark. So make sure you show us the direction of the vector and the label of that vector. The size of the vector does not matter. We are not marking, you're not giving you marks for the size of the vectors. We just want the direction and the name of that vector. If you don't have arrows, that thing is not a vector. Remember, a vector is direction and the size. So this is the free body diagram. There's weight, there's tension, because there's tension acting along the string. Because there's friction, so it's shown in the free body diagram, and this block is on the surface, there's normal force. Normal force is there when there's a surface. When an object is hanging, no normal force. And this is 4 marks, please. 1 mark for weight, 1 mark for normal force, 1 mark for tension, 1 mark for frictional force. 4 marks. 4 marks, but 4 marks. Let's draw the free body diagram of the other block, because we will need it in doing the calculations. So let's have it here. This is for P, and this is for Q. For Q, we are going to have the weight downwards. The normal. Okay, let's start with the normal force. The normal force up. Then the applied force is at an angle, so we need to show that this is F applied, or even if you wrote 40 newtons, and then there's tension. Now notice that there's tension going downwards. Is there friction? Is there friction on block Q? Nope, there's no friction, because while block Q moves on a frictionless section, there's no friction on block Q. So these are the only forces acting on block Q. This one is going to be resolved into its components, and this one is going to be resolved into its components. Remember, this one will give us FG parallel facing down and FG perpendicular facing down. Parallel, in the same line, along the same line as this is FG perpendicular, FG parallel. Don't show these forces in my free body diagram. For instance, I'm only using them to so that we will be able to do calculations. FG parallel and FG, parallel is this one is perpendicular. But when they say draw free body diagram, if you show the ones that I made some dotted lines, don't show this solid line. you will have that will be taken as extra force, and you lose 1 mark if you have an extra force. Now let's answer the next question. Calculate the magnitude of the acceleration. So they want acceleration of block P while block P is moving on section AB. Notice the examiner is careful here. OT block P. But what you need to remember, Wena, is that the 2 blocks they are like one system. Like if this was the truck, this will be the trailer. So they are acting as one system. If you find the acceleration of this one to be 10, the same will be the acceleration for block Q. So they are moving as one object. Let's move it up a bit so that they get more space in the paper below, because we'll need more space to solve this question. So, okay, wait, let's start it here and then we'll just extend it to the paper below. Number 1, we write, this is question 2. This is question 2, grade 12. Question 2, equation of Newton. It's Newton's laws. So now we are going to write, first thing, the formula that you write is you write Newton law 2. F net equals to MA. This formula is given in the formula sheet. And this will be, it is going to write F net equals to MA for block P, then we do the same for block Q. Then later on we'll solve them simultaneously. But let's start with P. F net equals to MA. All the forces that cause an acceleration to this object is all these forces along the incline. The frictional force, the weight, parallel component of the weight, and the tension. I mean the force that are on the same line as a motion. So this will be F net equals to MA. The forces will be, now in question 2 we choose direction. Question 2. So it means we have to choose the side that is positive and the one that is negative. Let us choose where the object is going as positive. Always choose where the object is going as positive. If you choose oppositely, the acceleration is wrong, because acceleration is going, most of the time acceleration is going when an object is going. So always choose when an object is going as positive. So we have minus, let's say tension, positive tension, minus frictional force, minus Fg parallel equals to mass and acceleration. The tension, we don't know the value of the tension. Frictional force is given to be 2.4. Then this one we can write, let's just write everything. So it's tension is positive because it's going up for block P, minus 2.5 newtons, minus, this is mg sine theta. Remember all the time, mg sine of the incline. So the mass of block P is 2, g is 9.8, then sine of the angle of incline, so this is sine 30, equals to the mass and acceleration. The mass is 2. Do we know the acceleration? No. If you don't know it, we leave it as that symbol. We don't know the acceleration, so we leave it like that. Then you can somehow calculate this. You will simplify it. Minus, this number will be negative. It's going to be negative 2.5. Remember to put this negative when you put this in the calculator. Negative 2.5 minus 2 times 9.8 times sine of 30, and then you'll get negative 12.3. Negative 12.3 equals to 2a. This is formula number 1. Let's just leave it as it is. It has 2 unknowns, tension and acceleration, so we leave it as it is. Now let's do for the other block. The other block, we write again Newton's second law for that block. Remember, there are 2 forces that needs to be resolved into its components. Here is the weight, the parallel and the perpendicular, and this force has the force Fx. Let's just call it Fax because the applied force in the x direction, and Fay. Say Fay. And this one it's useless to us if we don't have friction. It's useless. So it's only 1, 2, 3. It's tension, or parallel component of the weight, and the x component of the applied force. that move this object, or that are along the same line as the acceleration. So this will be minus tension. Notice now tension becomes negative in this one, minus FG parallel for this, for block Q, and then plus FAX, not just F applied, FAX equals to MA. Now let's substitute tension. We don't know. FG parallel for this one, it will be minus, the mass is 3 times 9.8, and sine of the incline. Choose FG parallel, sine of the incline, always. Plus, this one is plus because it's going up. So we chose like the up is positive. Now plus FAX, this is 40 cos 25, 40 cos 25 degrees. And that is all. This is the applied force in the x direction. This equals to the mass of the block is 3 and A. Then we're done. Normally this will be most the marks. Just doing this part is going to be a lot of marks. Actually 1 mark, but we don't know how this one was marked. Let's write minus tension. Let's put all these numbers in a calculator and get one number. So start with the negative because it's there. Negative 3 times 9.8 times sine of 30. Please verify my answers as you are checking out my videos. Then plus 40 cos 25. Last dollar 21 positive, ne? Positive, so it's positive 21.55 equals to 3A. These two formulas, they have two unknowns. Each one of them, the unknowns lay a acceleration with tension, and lay a acceleration with tension. So we solve them simultaneously. We can eliminate the tension and Cisalenge acceleration, or whichever method you use to solve these two equations simultaneously. But I prefer writing them like this: minus 12 t minus 12.3 equals to 2a. Then the R1 minus t plus 21.55. Because the tension, the two tensions they will always have different signs. If you add these formulas, you'll notice these two will be 0. T plus minus t is 0. Just add the two formulas. So we'll have negative 12.3 plus 21.55. Then these two will give me 0. Then lang plus 9.25. This equals to 5a. Causing this 18. Then the next step, I'm left with dividing by a both sides. Divide by a both sides. Let's divide by a. No, not by a. Excuse me. Divide by 5. Divide by 5 both sides. If we divide by a, we are not trying to achieve anything. So we must divide by 5 to get a equals to. This will be divide by 5. Divide by 5. 1.85 meters per second squared. The acceleration is meters per second squared. Notice if you redo these calculations, you'll notice my answer might be different because I rounded off here and I used my rounded off answer to continue solving. Just yeah, but it should be close to this. If you this your answer will be marked correct because you will have a range with this makanya. And then this will be given 5 marks. If formula is going to be marked once, this F net custom A only one mark. So if we mark it this side, we are not going to mark it on the other side. I'm just writing both sides so that it helps me now answer this thing. Now these people, this thing or this one, notice this thing or this one, any one of them, the mass times acceleration is given a mark. So write it all the time. One of them was going to be given mark. Doesn't matter if you don't write this one correctly, we will mark the one that you wrote correctly. So let's mark it this side, and then it means this substitution also be marked correct. Working out your answer and getting the answer, and working out your steps and getting an answer will be a mark also. I'm not sure if here the examiner will mark this part separate from that part, but I would mark it like that because this is another force and this is it's another force in an incline. I think to mark it like that is over fair. No, this will be marked alone, and then everything will be marked, I think, at so now 2, 3, 4, 5, 6, 7 marks. Maybe one more mark will be given for the method you use to solve and get the answer. Its acceleration, it's positive, and we chose up positive, so it means up the incline. This was given more marks than it deserves. So yeah, but this is how you do it. I'm not sure if how all the marks will be awarded, but this is how it's on a call. The last question says, if block P has now passed point B, so P now passes point B, how will its acceleration compare to that calculated in question 2.3? Choose greater than, smaller than, or equals to, and you have to give a reason. Now let's see. If P jumps over point B, one of the forces that was dragging it down is killed, so friction won't be there. What do we expect? Do you expect it to slow down or to move faster? There's no longer friction now. Both the blocks, the same forces applied, both the blocks are moving on a smooth surface. You obviously expect them to start speeding up, so the acceleration will be greater. The acceleration will be greater. 2.4, the acceleration will be greater. Why? There is no friction. You can write that now. There's no friction, which was the force that was opposing motion of this object. So no friction anymore. Or F net increases. You can write the net force increases. You can say F net increases. Because remember, F net was smaller because there was a frictional force. Now there's no frictional force, F net will increase. Frictional force is always opposite. So F net increases, any of the two. And that will give you 1 mark for greater, 1 mark for that reason. This is all that I have for now. Question 2 and question 5. Please subscribe to my YouTube channel and come watch more videos. Tomorrow I'll be doing one more topic on paper 1, and yeah, just keep on watching and get yourself ready. Thank you.